Greetings, this is Mr. Garwood with his continuing video series on Calculus 2nd edition by Briggs, Cochrane, and Gillette. Today we are looking in section 2.3, Techniques for Computing Limits, and I want to focus on the idea today of evaluating limits when they are given algebraically, that is, as a function formula, instead of graphically, as we discussed in section 2.2. We're going to start today with this example. So I've got that f of x is the piecewise function, where if x is less than -1, negative 2x plus 4 is the function rule, and if x is greater than 1, the square root of x minus 1 is the function rule. With piecewise functions, what we're going to do is we're going to look at, just as we did in section 2.2, what's going on from the left and the right of this breakpoint. And please note that, hey, look, for this, if my breakpoint for the piecewise function is 1, so I'm really curious, what is the function doing around 1? It's very easy to compute these if it's not 1. So if I look at a piecewise, of a number line, and I'm going to center it at 1, this function tells me that for every value including 1 or less, this negative 2x plus 4 is the rule that I'm going to use. And then for every function, this does not include 1, thus the open circle, I'm going to use the square root of x minus 1 as the rule. This follows very naturally with what we were doing in section 2.2, where we were computing left and right limits. And so let's do that now. So I'm going to start with the limit as x goes to 1 from the left. And looking at this, the one that's going to the left is the rule negative 2x plus 4. And what's nice is, provided I don't have any domain restrictions, I can just plug in the value for the limit that I am looking for. So if I plug in positive 1, into this function, I have no domain restrictions because this is linear and I don't have any issues. So all I'm doing is evaluating this function at 1 based on this rule. And negative 2 plus 4 is 2. So I can say that the limit as x goes to 1 from the left of f of x is 2. Similarly, I can do the same thing and evaluate this function at 1 from the right. So now I want to think here for a little bit. Let's make sure that I don't create a domain restriction when I plug in 1 for x. Well, 1 minus 1 is 0, so that's the square root of 0. And the square root of 0 is completely okay. This is not a domain restriction. It would be if I tried to plug in a negative number, and then we would have to deal with positives or a negative square root giving me complex numbers, and that's way outside where we're going to be in Calculus 1. So we're just going to focus here on the square root of 0 is 0. So now I have my left-hand limit, I have my right-hand limit, and so now I can look to see, is there just the limit of f of x as x goes to 1? Well, from 2.2 we said the rule was this and this have to match if that function exists. So that gives us that this function does not, the limit of this function at 1 does not exist. This function is fine at 1. The issue is the limit does not exist. Let's look at this graphically just to go back to what we were doing in section 2.2 or 2-2. So as we look here, as we go to the left, as we come from the left to 1, this clearly comes to 2. As we go from the right, this clearly goes to 0. There is a gap here. They are not the same, so our limit does not exist. Now let's take a look at another example. Oh, I apologize. This example is from figure 2.16, which is on page 55 in your text if you like to reference the text. Now here's another example. So once again, I have a function who has 2 rules, and that split point is when x is 3. So For everything less than 3 and including 3, I'm going to follow the rule negative 3x plus 9. And for every value greater than 3 but not including 3, I'm going to follow the rule x squared minus 9. So let's look what happens when we compute these limits. The limit, as x goes to 3, of x, and sometimes we'll actually go ahead and just go ahead and rewrite this limit statement. Limit as x goes to 3 of negative 3x plus 9. This is just a simple substitution. It means the same thing. Well, we said a minute ago that as long as we don't break the domain, we're okay to just evaluate this limit by plugging in the value. So I've got negative 3 times 3 plus 9. Plugging in this 3 does not cause me to divide by 0. I'm not taking the square root of a negative number. We're totally fine. Well, I've got negative 3 times 3, so that's negative 9 plus 9, which is 0. All right. So let's do the same thing. Oh, I did not note that this is the limit from the left. I apologize. This is the limit from the left. So let's do the same thing. Limit as x goes to 3 from the right of f of x, which would be the limit x goes to 3 from the right of the square root x squared minus 9. Well, we're going to have to see if there's a domain restriction here, but let's see what falls out. So this is just the square root of 3 squared minus 9. Well, the 3 squared is 9, so I've got 9 minus 9, square root 0. Not negative, we're okay. So the limit as x goes to 3 from the right of f of x is 0. So the question here now is, does the limit as x goes to 3 exist? So the rule says that it exists if the limit from the left and the limit from the right are the same. And since 0 equals 0, the limit does exist, and we can simply say that it is 0. Thank you for your time. I hope you find this video useful. Look forward to seeing you in our next video.